This example is asking us to find the tangent line to a parametric curve. So we know it's a parametric curve because we have this extra value in here, this t that pops up. Parametric curves typically have the letter t involved in it. What we are actually looking for to find is a tangent line. The fact that it's a line means that we have two things that we need to get, a slope and a point. And putting those together will get us our tangent line. So let's start off with our slope. Now, traditionally, our slope is going to be our change in y, or our dy, over our change of x dx. And that's what we are going to go for here. But we're going to do this a little bit piecemeal. Let's start off with, instead of dy, we know we have an equation with respect to t, so we can take the derivative of our equation with respect to t. Y is equal to 1/3 t cubed minus t, which means that dy dt, bring your 3 down. That's going to cancel with the 1/3, so we get t squared, and the derivative of t is 1. So our dy dt is t squared minus 1. We can do the same thing with our equation for x. X is 2 squared plus 1. So dx dt, bring our power down, and then plus 1, that's going to disappear. Whenever you don't know what to do in a calculus class, the best thing to do is take the derivative of something. Putting those two together, we have dy dx is the same as dy over dt on the numerator and dx over dt on the denominator. So we can just pop that into our equation, t squared minus 1 over 4t. Now, one last thing. I know there's still a lot of t's in here. Remember, we want to figure out what is going to happen at the point t is equal to 3. So we're going to punch in 3 into our equation. And when we do that, we are going to get our slope will end up being, well, let's see, we've got our t squared minus 1 over 4t. And punching in t is equal to 3. We get 9 minus 1 over 3 times 4, which is 12. So that's 8 over 12. And those both reduce. They both have a factor of 4 in them. I'll do this in 2 steps. This is a good thing to do for your brain. On a side note, if you struggle with this, that way you can just kind of practice your math. 8 is 2 times 4, 12 is 3 times 4, and our slope is 2/3. We cancel those out. Okay, so this is the first part of our solution. We know we need the 2/3, and that is going to give us our slope. Next up, we need to get a point. There's a couple things that we're going to do in here. And again, we're going to use the fact that we are looking at t is equal to 3. We know we have our x value is 2t squared plus 1. Punch in our t is equal to 3 into that, and we get 2 times 3 squared plus 1. 2 times 9, which is 18, plus 1. So our x value is 19. Our y is 1/3 t cubed minus t. We punch in t is equal to 3 there, and we have 1/3 3 cubed minus 3. So that is going to give us, well, 3 cubed divided by 3 is going to be 3 squared, so that'll give us a 9 minus 3, which gives us a value of 6. So our point, our x value is 19, and our y value is 6. So this gives us the second piece of information that we want, the 19,6. We have a slope and a point. We can now put them together to make our tangent line. Our line is going to use a simple formula. And the one that I like to use is y minus y1 is equal to m times x minus x1. we are going to go, our y1 is 6. Our m, our slope, is 2/3. And our x1 is 19. Now, depending on who you have as a teacher, you may be able to leave it like this because this is the equation of a line. However, if your teacher wants you to simplify, it doesn't take too much work, and you can get y is equal to 2/3 x minus 20/3. So that is the other way to write the solution there. So there is the tangent line to our parametric curve. Thank you for listening.